In this video, we're going to talk about 9.1 Objective 2, where we determine whether claims about the hypothesis test and statistical significance make sense. First question asks us to determine whether the following statement makes sense or is clearly true, or does not make sense or is clearly false, and explain. To learn about smartphone ownership, I chose a null hypothesis claiming that the proportion of adults who own a smartphone is equal to 0.8%. And the result of my hypothesis test proved this claim to be true. No, you can't say that it proved it to be true. So that doesn't make sense. The null hypothesis is good, but the hypothesis test cannot result in accepting or proving the null hypothesis. Determine whether the following statement makes sense or is clearly true, or does not make sense or is clearly false, and explain. The result of my hypothesis tests were statistically significant at the 0.01 level, so no one can doubt my claim any longer. No, that doesn't make sense. Just because you choose a small level for alpha, your level of significance, doesn't mean that there's no doubt any longer. The statistical significance at 0.01 implies that there's a 1% chance that the result that you came up with is wrong, leaving room for some reasonable doubt. It's small, and the smaller that you make alpha, the smaller the amount of doubt that's there, but you can't get alpha to be 0. You can't speak to this with 100% confidence. Question 3, decide whether the statement makes sense or is clearly true or does not make sense or is clearly false, and explain. In interpreting a p-value, capital P-value is a probability value that comes off of your z-table, typically is where we find that. So we also get that from our calculator, but we haven't talked about what a capital P-value is. In interpreting the capital P-value of 0.39 or 0.3900, because we usually look at it as 4 digits, a researcher states that the results are statistically significant because the p-value is less than 0.5, indicating that the results are not likely to occur by chance. No, that doesn't make sense. If we want to make a decision with p-value, we have to compare it to alpha, and alpha is not going to be 0.5, it's going to be 0.01 or 0.05 or something like that. So D, this doesn't make sense. A p-value of 0.39 corresponds to results that are likely to occur by chance. Just show you what that p-value of 0.39 means. It means that 39% chance here is less than, and let me grab a different color. You may want 1% or 5% here for your level of significance. Alpha equals maybe 0.1%. And so because your z-value that generated this p-value is not within your rejection region, not in that red region, because your p-value is bigger than alpha, then we would not reject our null hypothesis. It's likely that our mean that we got was different from the population mean just because of random chance. All right, again, we'll be doing a lot more of that, and I like making decisions based off of p-value because we can do that with our calculator and other statistical software, and it doesn't require a lot of drawing. So when we get there, that's my preferred way to do it, but I'll show you all the different ways that the textbook on my lab show you how to make a decision. So we'll come back next time and talk about 9.1 Objective 3. See you for the next video.